Well, welcome back to another video. This is basically my solution walkthrough to the latest VCAA sample exam question for specialist math. So this video will go through the sample questions for written exam 1. Now, I need to make this disclaimer. What I express in this video is just my personal opinion for pedagogical uses for my own students. And this is in no way endorsed by VCAA in any form. And this video is not for any profit, non-for-profit purposes. All right. And let's have a look at the first question. The first question is looking at a proof by induction problem. So we consider the statement half plus quarter plus 1/8 plus until 1/2 to the power of n equals to 1 minus 1/2 to the power of n. N is any natural number. So let's say n equals to 1, 2, 3, blah, blah, blah. So first part, show that if n equals to 1, the statement is true. This is very easy because left-hand side, when n equals to 1, it's just first term, half, okay? And the right-hand side is going to be 1 minus 1/2, which is half. Therefore, it's equal to left-hand side. So let's say this statement is proposition bracket n. Therefore, when n equals to 1, P1 is true. Now, assume that a statement is true for some n equals to k, where k is also a natural number. And we want to write down the assumption in terms of k, which means I'm going to substitute n equals to k into both sides of the statement. So it's half plus a quarter plus 1/8 plus ... until I add to 1/2 to the power of k equals to 1 minus 1/2 to the power of k. Okay, so this is my P of k. Okay. Hence, proof by mathematical induction that half plus a quarter plus 1/8 plus until you add to 1 to the power of n equals to the right-hand side. Okay, so this is what we call an inductive step. So we need to show P of k plus 1 is true, given P of k is true. Now, the left-hand side of Pk plus 1 is going to be 1/2 plus 1/4 plus 1/8 plus ... plus 1/2 to the power of k at 1/2 to the power of k plus 1, which means, okay, now I add until the k plus 1 term. So I'm going to use my previous assumption, which means because P of k is true, left-hand side is equal to the right-hand side. All right, I simply change the first k terms in terms of 1 minus 1/2 to the power of k plus 1/2 to the power of k plus 1. This can be written as 2 times 2 to the power of k, okay? And the next job is to combine the last two terms, which means I'm going to write 1 minus 2/2 times 2 to the power of k plus 1/2 times 2 to the power of k. So these two terms can be written as 1/2 times 2 to the power of k. And therefore, it's going to be 1 minus 1/2 to the power of k plus 1, okay? And this is exactly what we want to see, because if you want this statement to hold true, when you swap the k here, you should have a k here. When you swap the n, let's say, to k plus 1, you want to see exactly a k plus 1 here. Therefore, I'm going to say equals to the right-hand side of pk plus 1. So if pk is true, then P of k plus 1 is true. Therefore, by the principle of mathematical induction, P of n is true. For any n belongs to natural number set. Okay, so this is my solution to the first question. All right, let's have a look at the next question. Consider the inequality 2 to the power of n greater than n to the power squared, n squared, for some n greater than or equal to n naught, where n is also a natural number. We want to show that the first n, this is my value for the base case, is equal to 5. So what I'm trying to do is I construct the table as in the suggested video delivered by VCAA. And let's say 2 to the power of n, n squared. When n equals to 1, this is 2 to the power of 1 is 2. And this is 1. But then let's have a look at 2 here. 2 to the power of 2 is 4. And n to the power of 2 is still 4. Well, even though we have 2 greater than 1, satisfying the first case, the second case, they are equal to each other, which means this is not true. So we're going to look at the next n value. So you're going to see 2 to the power of 3 is 8. And 3 to the power of 2 is 9. This time a is 8 less than 9. So I'm going to try the next one. Okay. So 2 to the power of 4 is 16. And 4 squared is 16. They're still equal to each other. Well, we want this pattern to be always true for the very first value onwards. Okay. Now I'm going to see a 32, 2 to the power of 5, and 25. Okay. So this pattern starts to emerge. When I substitute n equals to 6, I'm going to get 64. And 6 to the power 2, that will be 36. Greater than, equals to, less than, equals to, greater than. So from n equals to 5 onwards, for the pattern to be true. Okay. Well, we still need to use mathematical induction to prove that 2 to the power of n is greater than n squared for all natural number n greater than or equal to 5. Now, let P of n be the statement 2 to the power of n greater than n squared. N is greater than or equal to 5, and n is any natural number. Base case, P of 5 is true, because we've done that in part A. Then, assumption. For mathematical induction, we need to assume that P of k is true. For any k greater than or equal to 5, this is one part of our assumption, and the k is also a natural number, okay? All right. Then we look at, okay, let's write this a statement explicitly. 2 to the power of k is greater than k to the power squared, okay? Now let's check pk plus 1, okay? Left-hand side of pk plus 1 is going to be 2 to the power of, let's say, k plus 1. Well, we can use the similar approach in the previous question. This is equal to 2 times 2 to the power of k. 2 lots of 2 to the power of k, that means 2 to the power of k plus 2 to the power of k, okay? Now, because we know 2 to the power of k is greater than k squared, that means this quantity, we can change one lot of 2 to the power of k to k squared. But then it's going to be greater than 2 to the power of k plus k squared, okay? That also means I can change this, for example, one of the 2 to the power k to k squared, okay? So this is equal to 2 to the power of k squared, but we still want to show this bit is strictly greater than the right-hand side. All right, now why don't we just pick and choose one of the two k-squares? This is going to be greater than or equal to k squared plus k times k, right? And then I'm going to change, for example, this bit to be 5, okay? And then I can follow on these steps to establish a pattern here. From this moment on, it sounds a bit strange for most of us. Well, how could I proceed? If we have no idea on how to proceed, then we think about anything related to quadratic functions. Normally, what we learned in quadratic functions when we were doing Unit 1, 2 math method or Unit 11 methods, well, we could complete the square. So how could I complete square in a meaningful way? Well, I could write this one as greater than or equal to k squared plus, if we had a 2k here, then it's followed by, let's say, 3k, right? And don't forget, because k is greater than or equal to 5, then 3k is greater than or equal to 15. That means the quantity is going to be greater than or equal to k squared plus 2k plus 15. Whoa. So I'm going to say, okay, this is going to be k squared plus 2k plus 1 plus 14. And this is going to be k plus 1 whole thing squared plus 14, okay? So we've successfully established a meaningful pattern here. But if you can't see them directly, think backwards. What does pk plus 1 mean? That means 2 to the power of k plus 1 is greater than k plus 1 whole thing squared. That's totally what we want to prove or what we want to show. Well, we have successfully manipulated so far the right-hand side or the left-hand side of the inequality. Then let's just tidy up what we had here. So 2 to the power of k plus 1 could be greater than or equal to k plus 1 squared plus 14. And if you subtract the 14 from the right-hand side, that means your 2 to the power of k plus 1 is strictly greater than k plus 1 squared. Therefore, if pk is true, pk plus 1 is also true, okay? By the principle of mathematical induction, we can see the original proposition. P of n is true for n greater than or equal to 5, and n is any natural number satisfying greater than or equal to 5, okay? Well, we probably want to make some annotations here, for example. From this step, we used, let's say, P of k, okay? And from here to here, we used k is greater than or equal to 5. And from here to here, we also used the k is greater than or equal to 5 as part of our assumption at the beginning. All right? Quite a bit to write for 3 marks question, I suppose. And then let's have a look at the next question. Well, prove by mathematical induction that the number of 9 to the power of n minus 5 to the power of n is divisible by 4 for all natural numbers small n. So let P of n be the statement 9 to the power of n minus 5 to the power of n equals to, let's say, 4. Don't want to use k here because later on I'm going to use the letter k. It's a reserved letter for our inductive steps. So I'm going to say 4p, okay? Because our calculation only involves natural numbers. Here, I'm going to say P is any possible natural number, and N is also any possible natural numbers. All right, check the base case. Base case, P1. Left-hand side is going to be 9 minus 5 equals to 4. And the right-hand side, well, when P is equal to 1, equals to left-hand side. Well, even though we picked a value of P here, we still satisfy our purpose. Therefore, it is divisible by 4. Okay? All right, now let's check PK plus 1. Assume that PK is true, which means in our inductive step, I'm going to use the statement here, 9 to the power of n minus 5 to the power of n equals to 4p, okay? Right, so we start off using the left-hand side of PK plus 1. That equals to 9 to the power of k. Well, I made a mistake here. I didn't realize I just wrote n, so I'm going to say 9 to the power of k minus 5 to the power of k. Well, technically speaking, I should say, doesn't matter. I can use p here. 9 to the power of k. Let's come back to the pk plus 1 step. Subtract 5 to the power of k plus 1. So what I'm trying to do here is, okay, I can write this as 9 times 9 to the power of k. Subtract 5 times 5 to the power of k. Once we did some small manipulations using the index law, we need to manipulate some part or both parts to match something in our assumption. Well, in that case, I could say 5 to the power of k is going to be, let's say, 9k minus 4p, if I'm not mistaken, because I just rearranged that a little bit, okay? So I'm going to say 9 times 9 to the power of k, subtract 5 times bracket 9 to the power of k minus 4p. Make a small annotation here as p of k is true, okay? This is exactly what we're using the rearranged version of our assumption involving parameter k. Okay, now let's just merge everything as much as we can. 9 times 9 to the power of k minus 5 times 9 to the power of k plus, well, this is going to be 20p, okay? And then some magic just happens. 9 minus 5 times the common factor 9k plus 4 times 5p, okay? So this is going to be 4 lots of 9 to the power of k plus 4 times 5p. Whoa, very happy with that result because our target is to show, well, if the previous expression involving k is a multiple of 4, then the next, the k plus 1 term is also a multiple of 4. 4 lots of 9 to the power of k plus 5p, okay? Which is also divisible by 4. And it satisfies the form 4 lots of a natural number. Therefore, by mathematical induction, 9 to the power of m subtract 5 to the power of n is divisible by 4. For any n belongs to natural number 1, 2, 3, 4, 5, 6, blah, blah, blah. Okay, so you could, in your own working, have a slightly different variation in the middle. For example, some student may choose to do 9 times 9 to the power of k, subtract, let's say, 9 times 5 to the power of k, then add a 4 times 5 to the power of k, which is also equivalent to what I'm doing here without any substitution. This is also a very smart manipulation here, okay? As long as you show everything clearly, in my opinion. Okay, finished. induction questions. Now this is another interesting question. Use proof by contradiction to prove that if n is odd, where n is any natural number, then n cubed plus 1 is even. In this case, even though a direct proof is very obvious, if you say n equals to 2k plus 1 or 2k minus 1, substitute and expand. Yep, you can prove that's an even number. But here, the most important message, I suppose, we have to follow the instruction here. If we didn't use the proof by contradiction as instructed, highly likely no marks would be awarded to other method unless they say use proof by contradiction or otherwise. Okay, so I'm going to start the proof by contradiction by assuming the opposite. Assume that if n is odd, n is at any natural number, then I'm assuming the opposite of the conclusion. N cubed plus 1 is odd. Okay. So let n equals to 2k plus 1. Then n cubed plus 1 is going to be 2k plus 1 cubed plus 1. Well, this Pascal triangle expansion 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. What I'm going to do is to expand the first bit 2k to the power of 3 plus 3 times 2k squared times 1 plus 3 times 2k plus times 1. Bear with me. 1 squared plus 1. A common misunderstanding here is to omit the plus 1 here. Remember, these 4 terms corresponds to the expanded version of this triple power, and then you still need to add 1, okay, at the end, coming from the previous line. So I'm going to say 8k to the power of 3 plus 12k squared plus 6k plus 2. Well, you have 4 parts, 4 terms. They are all, by the way, you need to mention k is also a natural number, okay? Because k is a natural number, the 4 terms are all natural numbers, but they are all multiple of 2. They are all even, okay? And this whole expression must be even. So the key of proof by contradiction is that once you find a contradiction in your working against any truth, fact, or theorem, well, your assumption is wrong. That means the opposite of your assumption, which was the original statement, it has to be true, okay? So this contradicts our assumption. This is false. Therefore, the original statement is true. Okay, so that's the essence of proof by contradiction. You assume the opposite, then you show some working and arrived at a contradicted result to any theorem, fact, or mathematical knowledge. And eventually you're going to say, okay, the opposite, which was the original statement, it has to be true. Okay, so that's question 4. Right, another proof by contradiction to prove that root 3 plus root 5 is greater than root 11. Well, there are various means to tackle this problem, but what I'm trying to do is, okay, firstly, follow this instruction. Use proof by contradiction. Assume that root 3 plus root 5 less than or equal to root 11, okay? Be very careful with that. The opposite of greater than is less than or equal to, okay? Then, well, because you have 2 terms added together and you want to show some inequality, I suppose we have the AMGM inequality, right? If you remember that. Now, I suppose this is a very common result you should be using. for any two x plus y, x and y, x plus y divided by 2 is greater than or equal to root xy, okay? Now, use the AM, arithmetic mean, and a geometric mean inequality. We should see root 3 plus root 5 is actually greater than or equal to 2 lots of root. Make sure you realize it's 2 roots under roots, okay? Because that's your x, that's your y, divided by 2 is greater than root xy. So you multiply both sides by 2. So now I'm going to manipulate the right-hand side, which means that will be under a square root, you have a 4. Bring in the 2 outside, inside the square root, and root 15. So what does root 15 mean? Root 15, I would say, root 15, well, let's have a look at 4 here. So I'm going to say 4 equals to root 16. What I'm trying to do is I will make this 4 another root 16 multiplied by root 15. So I'm going to get root. What is root 16 times root 15? 16 times 15. Okay, that will be 80 plus 160. 240, which means I can write this one as 240 to the power of quarter. Okay. So what I'm trying to do is to establish a contradiction again. Now, note that root 11 is actually root 121, okay? Which means it's 121 to the power of a quarter, okay? 240 to the power of a quarter is definitely greater than 121 to the power of a quarter. So that means our assumption is false. Therefore, the opposite has to be true. Okay? Remember, the essence of proof by contradiction is the truth table here. Not sure if you are familiar with the logic table or not. So consider a statement P and the negation of P, or let's say P dash. If P is true, the opposite must be false. If the original is false, then the opposite must be true, okay? It's just like two sides of a coin. All right, so that's one possible approach. Another possible approach is to manipulate the inequality, okay, in a meaningful way. I'm going to organize my writing a bit and have some extra space on the right side column, okay? All right, so another possibility is that we're still using the same assumption here. We start with this assumption. But now, then, if that's true, we can follow on by squaring both sides without changing the inequality direction. That means 3 plus 2 root 15. Root 3 times root 5 plus 5 is less than or equal to 11. So 2 lots of root 15 should be less than or equal to, let's say 11 minus 8 is 3. But 2 root 15 equals to, I already calculated that, it's 4 times 15 root 60. And the 3 equals to root 9. Root 60 is definitely greater than 9, which contradicting our previous steps. So the assumption is wrong. And the original statement is true. √3 plus √5 greater than √11. Okay. Notice that you should not argue from the decimal approximations. Say, √3 is 1.732 blah blah blah, and the √5 is 2.24 blah blah blah, etc. Okay. You have to show some algebra work. All right, now calculus part. Even though you may not have touched on this bit, later, eventually in your revision time or learning time, you may want to look at these questions. So I'm going to go through the rest of the questions in details. Now the curve given by y equals to √4 minus x squared, where x goes from -1 to 1, is rotated about the x-axis to form a solid of revolution. Find the surface area of the solid of revolution. So you need to recall from the VCAA formula sheet. Now they published a new latest version of the official formula sheet. So what does this graph look like? This graph is a half circle, okay? Top half. There is my drawing. Okay, so I'm going to delete everything. And the radius is definitely 2, okay? So now from -1 to 1 here, you are rotating this bit. You should be able to form something like that, okay? Like a pumpkin, similar to a shape of a pumpkin, okay? But we are only looking at the surface area of this solid of revolution, which means the curved surface, okay? So what I'm trying to do is rotate it about the x-axis, hold the formula. Surface area is going to be the integration, let's say 2 pi, the integration from -1 to 1, y times square root 1 plus your dy dx, bracket square dx, okay? And by symmetry, this can be written as 2 lots of 2 pi y blah blah blah. So it's going to be 4 pi from 0 to 1, because -1 and 1, they are symmetrical around the y-axis. In the later working, you can simplify your calculation if you use your symmetry wisely. So y is going to be 4 minus x squared, and then the bigger square root is just 1 plus what's the dy dx? Well, if y equals to √4 minus x squared, under the square root you use some chain rule, so it's going to be -2x. The derivative of the inside divided by 2 lots of the square root, original square root. So you're going to get -x over √4 minus x squared. Now you are going to square that term. Don't forget you need to square that term, and don't forget your dx, okay, your infinitesimal. So -x, 2 roots, no 2, just √4 minus x squared. All right, then 4 pi 0 to 1 √4 minus x squared, bigger square root 1 plus x squared divided by 4 minus x squared dx, okay? And then 4 pi integration 0 to 1 √4 minus x squared. What you can do with respect to the second square root, just combine 2 parts. Taking the common denominator, you should be able to see it's 4 minus x squared plus x squared on top, okay? Well, they cancels out nicely. Cancelled out nicely, so you should have 4 pi from 0 to 1 √4 minus x squared. Well, it's let's say √4 divided by √4 minus x squared. So I'm going to get a 2 over square root 4 minus x squared dx. Well, simple and nice. So 4 pi times integration 0 to 1 2 dx. What I'm doing here is integrating that with respect to x. So you should get 4 pi times 2x from 0 to 1. Therefore, the answer should be 8 pi, okay? So 8 pi is the curved surface area from rotation, okay? And notice the phrase of the question. If the question says the curved surface area or just the surface area, just find the area from rotation. But if it's closed surface area, you need to consider the two ends. There are two circular surfaces, top and bottom. Whichever is the top, whichever is the bottom. You need to calculate by pi r squared times 2 and add on the curved surface area. Let me just make an annotation here. This is the curved or side surface area. Okay. All right, that's it for question 6. And let's move on to the next question. All right. The curve given by y equals to cube root of x. It's not 3 lots of square root of x. It's a cube root of x. Is rotated about the y-axis. Be aware of this phrase here, okay? Now, you're going to use the correct version of your formula. So, you're going to hold it here. Surface area of this part of the solid of revolution x from 0 to a. So, basically, the cube root function looks like that. If x equals to 8, I suppose the y value is 2, okay? Your number solution is 2, okay? And this is 0. So I'm going to form let's say a horn like that, okay? A horn. Okay, now I want to find the surface area. Now, basically, the surface area for the functional form s equals to 2 pi. If it's rotated about y, you are going to use y1 and y2 as your terminals. This is just a 2 pi x root 1 plus the x dy bracket dy, okay? You can also find that on your formulation. Right, so because y equals to cube root of x will be y to the power of 3, okay? The other way around. So what I'm trying to do is do it bits by bits. Y dx, dx dy, that would be 3y squared, okay? Terminals. Y equals to 0, y equals to 2. When x equals to 0, x equals to 8, okay? So the surface area is equal to 2 lots of pi from y equals to 0, y equals to 2. Now you don't need to write out y. This is just telling myself I'm integrating with respect to y, okay? So x, what is my x here? My x is y cubed. Square root 1 plus, for example, 3y squared. Again, if that's squared, that would be 9y, say, power 4 dy, okay? And note, this is a 5 marks question. It does need to involve a certain amount of working to derive at the correct answer. Okay, now, if you look at the structure of the integral, we successfully developed an integral here. Then the next job is to find the antiderivative and then sub in the terminals, do the subtraction and calculate the answer. So you need to know how to integrate that thing. Well, I could make this one, let's say, inside the square root. If I see a structure, I let it be u. I probably need to use a blue color here. Let u equals to 1 plus 9y to the power of 4. So du dy is going to be 36y to the power of 3. And this chunk will be 1 over 36 du together with dy, okay? For example, I could say 1 over 36 du equals to y cubed times dy, okay? I'm just making this differential form up. All right, and don't forget, you need to adjust the terminals from y values to u values. When y equals to 0, u equals to 1. When y equals to 2, u equal to 1 plus 9 times, well, that's 16. So you're going to get 1 plus 9 times 6. So 6. Oh, 9 times 6. Fix that. And 54 plus 90. So I'm going to get 144. Okay. So 1 plus 144, that would be 145. Okay. So the whole integral should be 2 pi u equals to 1, u equals to 145. And this is just a whole chunk of square root of u times 1 over 36 du. Remember, you can also cancel out the constant. So I'm going to get pi over 18 integral from 1 to 145 u to the power of pi du. Well, this just reduces to a very simple index power function integral. I'm going to get integral of 1 to 145. If we add to derive a power function, we raise the power by 1 divided by the reciprocal of that new power, 2 over 3. Okay. And don't forget, you can keep simplifying things down. For example, 1 and 9 here. So eventually your constant in front of the evaluation is 7. Okay. U to the power of 3 over 2. 1 to 145. And the last thing you want to do is simply substitute and subtract. So it's going to be 145 to the power of 3 over 2, subtract 1 to whatever power, that's just 1, okay? This is your final answer. You could also write it as pi over 27 times 145, root 145. Take 1, bracket, that's it, okay? Right, quite a bit for 5 marks question. Let's have a look at the next question. Whoa, another nice question. Determine the surface area obtained by rotating the curve by the parametric equations x equals to something theta, y equals to something theta about the y-axis. Okay, so I'm not going to flip to the formula sheet. In fact, if it's rotated about the y-axis, what I'm doing here is the surface area equals to 2 pi integral. Now it's with respect to theta. If it's with respect to t, it's t. With respect to theta, it's theta. Theta 1, theta 2. Now it's about the y-axis, so I'm going to say x of function theta times the square root outside the root, you should have the x in theta bracket squared here and y in theta bracket squared. Okay, so we need to use the terminals 0 to half pi. That's easy, but here the most important thing is to get the derivatives correct, because x equals to sine theta to the power of 3. Okay, y equals to cosine theta to the power of 3. You need to use chain root to differentiate. Otherwise, simply say 3 sine squared. That's wrong. Differentiate that to get 3 sine squared theta times cosine theta. Okay, and you get a dy d theta. That will be 3 cosine squared theta times the negative of sine theta. All right. If you miss that negative, that's not quite right. All right, now this is going to be minus 3 cos squared theta times sine theta. What I'm trying to do eventually is to evaluate this bit and simplify this bit, okay? So it's like later on, if you deal with arc length problem, similar to that context. It was a similar question in 2017, specialist maths exam 1, if I remember that correctly. You need to find the x d theta squared plus the y d theta squared, which means you can always simplify whatever under the square root first, and then do the evaluation, rather than chop everything and then make your evaluation long and painful. So square dx d theta, that would be 9 sine squared theta, becomes power 4, right? Sine to the power 4 theta, cosine squared theta, plus 9 squared the negative becomes positive, cosine to the power 4 theta, sine squared theta. All right, there you just observe we can take out the common factor 9 sine squared, cosine squared. Okay, so the first bit has sine squared remaining, and the second bit has a cosine squared remaining. Everything just like an apple, nicely falls out. This is 1. So this is going to be 9 sine squared theta, cosine squared theta. Okay. And don't you ever forget that you have an x theta in your formulation. Okay. So when you square root that, now, when you square root that, you just put a square root on each step you have already. And don't forget your domain restriction for the parameter, as theta is from 0 to half pi. This is an acute angle, okay? Acute angle. Therefore, sine theta, cosine theta, they should all belong to 0 to 1. That's why when you take the square root, you just simply write 3 sine theta cos theta without writing, for example, an absolute value, okay? No absolute value needed. So our next job is to chart this back, and x of theta back. S is going to be 2 pi from 0 to half pi. And this is going to be sine cubed theta times 3 sine theta cosine theta d theta. Don't forget that. Bring out a constant, it becomes 6 pi to half pi, and sine to the power 4 times cosine theta d theta. Suppose many people, if you're very smart, well, suppose all of you are very smart, you can look at a pattern here. The derivative of sine is cosine, and is sine to the power 4. Well, you're not necessarily doing a substitution here, but if you really wish, it's possible. But don't forget to change the variables, okay? You need to change the variable if your integral is in terms of a new letter, okay? This is very crucial. Actually, theta is 0, u is 0, theta is half pi, u is 1, okay? So what I'm going to write is 6 pi from 0 to 1, u to the power 4, d. This is your d, okay? And I should get a 6 pi over 5, u to the power 5, 0 to 1. So the answer is very nice and simple. And time 6 pi over 5, okay? Not a 4 marks question. Yep, should be right. 4 marks. Fair. Okay, now question 9. Question 9, find the surface area of revolution formed when the curve defined by the parametric equations x equals to that bit, y equals to that bit, t is given to you, is rotated about the x-axis. So now I'm going to chant the surface area formula again, t1 to t2 y square root of dx dt squared plus dy dt squared dt, okay? So x is going to be 4 over 3, t plus 1 to the power of 3 over 2. And the y is going to be half t squared. So dx dt is going to be 4 on 3 times 3 over 2 times t plus 1 to the power half, which means I'm going to get two lots of root t plus 1. And the dy dt is very simple here, so it's going to be t, okay? 2 over 2 is 1. Now the surface area is 2 pi from 0 to 1. And y is half t squared root 2t plus 1. That's going to be square that. That'll be 4t plus 1 plus t squared. Remember, it's dx dt squared, okay? If you square that, that's going to be 4t plus 1 with a bracket. If you square that, that's just t squared, okay? And don't forget your infinitesimal dt, okay? Now, what you want to see is whether you can find a perfect square under the square root, okay? So what I'm doing here is rewrite this one, expanding it to be t squared plus 4t plus 4 dt. Don't drop off your dt. 0 to 1, half t squared. Well, within the square root, it's indeed t plus 2 squared dt, okay? But that means it's about the main restriction. Normally, root a squared is absolute a, but if a is greater than 0, root a squared is just a, okay? So from 0 to 1, I suppose t plus 2 is greater than or equal to 2, less than or equal to 3. So 2 pi integration 0 to 1 half t squared times t plus 2 dt. Okay. Okay, I ran out of space on the left column, so I'm going to rule up my page and write it on the right. Okay. When you are answering the questions, make sure you rule up the page like what I'm doing here. That will maximize the use of your line space and make your answer more logical. So S equals to 2 pi integral from 0 to 1 half t cubed plus t. If that's correct, yeah. 2t squared. Double check your calculation here. Avoid simple mistakes. There's no stupid mistakes. 2 pi, if I bring in the 2, that will be t to the power of 3 plus 2t squared, bracket dt. So I'm going to get pi, a quarter t to the power of 4 plus 2 over 3t to the power of 3, from 0 to 1. So pi, a quarter plus 2 over 3 minus 0 minus 0. So pi, that would be 3 over 12 plus 8 over 12. So 11 pi over 12, okay? And that will be my final answer. Note here, please note. You need to simplify as much as possible, okay? But I do think this question are, well, quite a bit working, even though all the steps are very simple. 3 marks. I wish they could allocate this one as 4 marks, but anyway, let's have a look at question 10. The population of bacteria P of T in a Petri dish satisfies the logistic differential equation. Well, logistic differential equation, it was already in the previous study design, but well, anyway, it's another stress point in the latest, in the current study design. T is measured in hours, and the initial population is 4,000 bacteria. So find the maximum of bacteria predicted by this model. In that case, if you think of the relation between T and population, you have a least upper bound here, which is the horizontal asymptote equals to something. That is obtained by limiting your, rate of change, limiting your rate of change to 0. So you reach some sort of equilibrium here, flat gradient, but it's only approaching to a flat gradient, never equals to a flat gradient. So we don't want P equals to 0 because we want to seek for some maximum sort of number. Well, it's not a stationary maximum. It's just an upper bound, okay? An upper bound. horizontal asymptote. So I want to make sure 6 minus p over 8,000 equals to 0. It's approaching to 0, okay? Technically speaking, I'm saying approaching to 0 rather than equals to 0. So p over 8,000 approaches to 6, and p should be approaching to 4,800, okay? Multiply everything by 8,000. So this is 4,800. And find the number of bacteria when population is growing at fastest rate. Well, you start off with the 4,000 bacteria. Initial phase of this graph, it's going to increase, or the growth is getting faster and faster. But once it reached half of the capacity, the carrying capacity of the bacteria, it slows down, okay, and getting closer and closer towards the, horizontal asymptote. That's what happens here, okay. All right, now if I want to find that one, well, we have various approaches. You could either go for second derivative and implicit differentiation, or just look at, let's say, look at my labeling here. Be aware of the labeling. Well, indeed, it's a logistic curve involving exponentials if I look at a p versus t. But if you treat these as y, these as x, the p dt is your rate of change with respect to p. This is a concave down parabola. This is 0. This is 4,800. It's a concave down parabola. Does that make sense? In the middle, you reach the maximum rate of change, growing at its fastest rate, okay? 2,4,000. Say, use symmetry of the PDT versus P graph. P equals to 4,800 plus 0 divided by 2, which is 2,4,000, okay? Bacteria. The question wants exactly the number P here. They don't need you to find the time yet. And we haven't got the relation between P and T. That's the next part. We want to solve this differential equation. Well, since this is a 2 marks question, you do need to show some explanations or diagrams for working here. Another possibility is if you used your, let's say, implicit differentiation, you could start off by differentiating expanded version. Something along these lines, okay? So you could say, or the 2p dt squared is going to be, firstly, you derive the p dt with respect to p, then multiply by the p dt. This is chain rule differentiation. Now you could get 12 minus p over 2000 as one term, then multiply by the p dt. I don't care what the p dt is, because you want the maximum rate of change. Max rate when the second derivative equals to 0, but your first derivative cannot be 0, otherwise it has to be a stationary point of inflection, okay? So I'm going to say 12 minus p over 2,000 equals to 0. Therefore, p equals to 2,4,000, okay? So that's another possible approach if you really want to use some calculus here, all right? Okay, now solve the differential equation as a function of t. Well, we had 4 marks here. That also means we need to demonstrate this. Well, you could argue that you can just chant the 1 plus something t minus rt thing here, but no, because that's a lot of marks. We better start off with the given differential equation here, not just memorize it, but rote learning the general solution to the logistic differential equation. Okay, so here let's just make a screenshot for reference. Make a screenshot for reference. Let's have a look here. Okay, and the initial condition is was t equals to 0, p equals to 4,000. And the such quite a bit of math working here, so I'm going to rule out my right place in two columns. Firstly, I need to write the dp in a meaningful way. For example, that's p, well, minus p over 4,000, okay? Well, later on, I'm going to flip that and show some integration. So I'm going to combine the second bracket as follows. So I'm going to say 4,000 here, 4,800 here, subtract p. Now, if you flip that differential equation, you get p equal to 4,000 divided by 4,800 minus p times p, okay? It goes with the original numerator. Once you flip that, it's going to be your part of your numerator, okay? Correct flipping, or let's say separation of variables. Now I'm going to say this thing is going to be split or decomposed into a partial fraction form. Something along these lines, okay? So partial fractions. A times 4,800p. Basically, I just recombine the right-hand side of this partial fraction form. B times p equals to the original numerator, 4,000. So if you substitute p equals to 0, 4,880,000 lots of a equals to 4,000. So a is going to be 1 over 12. If p is 4,800, 4,800b. It's going to be 4,000, which means it turns out nicely 1 over 12. So this is your differential equation. dt dp equals to 1 out of 12 times 1 over p plus 1 over 4,800 minus p. Now it's time to separate the variables, and I could also multiply the 12 to the other side. 12 lots of dt equals to integration 1 over p plus 1 over 4,800 minus p dp. So you are anti-differentiate both sides, and the right-hand side you're getting logs, natural logs. So 12t equals to log e. Well, in this case, because p is a bacterial number, it's a positive quantity. I don't involve any absolute value here, okay? Make sure you state that. As p is greater than 0, but less than 4,800, no absolute value. So now we are halfway through, but we still need to find the integration constant c, sorry. So t equals to 0, p equals to 4,000. That means 0 is going to be log e 4,000 divided by minus. Then subtracting logs becomes dividing the arguments. So I'm going to say 4,4,0,0 plus c. This can be canceled down to 1 over 11, okay? And I should get, okay, c equals to negative log e 1 over 11, which means this is going to be log e 11, okay? Log e 11. All right, now recombine everything together. Let's put an arrow here, okay? 12t equals to log e 11p divided by 4,800 minus p. So now I'm going to manipulate and get the p in terms of t, because that's exactly what the question has been asking for. So e to the power of 12t is going to be the argument 11p divided by 4,800 minus p. And I could flip that around or multiply both sides. So let's try to flip both sides. Then your reciprocal will be taken e to the power of negative 12t or 8,000 subtract t divided by 11t. Multiply 11 both sides, you should get it. 11e minus 12t equals to 4,8,000 divided by p, subtract p over p, okay? So you should get 11e minus 12t equals to 4,8,000 divided by p, subtract 1. So 4,8,000 divided by p is 11e to the power minus 12t plus 1. And if you switch these two parts, the equation is still true. So your p is going to be 4,8,000 divided by 11e minus 12t plus 1. And that is the required form, I suppose. The p as a function of t. Of course, if you multiply the top and the bottom by e to the power of 12t, it's still equivalent, okay? So that is my suggested approach to tackle this differential equation problem. Well, you could have other variations, but make sure you demonstrate sufficient work because this question was 4 marks, okay? And it comes to our attention that, integration by parts is the next big thing in the new study design. So I'm going to just tidy this up a bit. Make this one smaller. All right, let's have a look at the next question. Find x squared equal 2x dx. So let's rechanting the integration by part formula. Well, previously we have been dealing with integration by recognition. Do the product rule first. Well, the version on VCAA formula sheet is dv dx times u dx equals to the u times v subtracting the u dx times v dx, okay? Now, what is your u, what is your v? That requires you to think carefully. So let u equals to x squared, v equals to cosine 2x. Actually, sorry, v dx, not v. Then you should get the u dx by differentiating, but then v by anti-differentiating. This will be half sine 2x. Without the add c, we add c at the end, okay? In the middle steps, don't add c. At the end, we add c, okay? So the integral equals to x squared cosine 2x dx is going to be u times v half x squared times sine 2x, okay? Subtract your du dx is 2x times v, which is half sine 2x dx. Let's just tidy this up a bit. Half x squared times sine 2x. Subtract x times sine 2x dx. Okay. Actually, we need to repeat the integration by parts process again. So on the side, I will do some side work, but make sure I clearly label everything. Let's say let I2 is this bit here, okay? I2 equals to integral x times sine 2x dx. Well, there is one thing to note in your integration by parts. When you first set your x squared as your u and dv dx as your trig function, then you should do the similar thing by setting these as your u and this is your trig function, okay? Don't swap them around. Otherwise, you will end up with endless circulations, which doesn't help you at all. So you're gonna get, okay, u equals to x. then your du dx is going to be 1. dv dx is your sine 2x. Be aware of the sign change. Integrating sign will give you minus half cosine 2x, okay? So I2 will be equal to UV minus du dx times v dx. So this will be minus half cosine 2x times x. Subtract integral of du dx times v, which is minus half cosine 2x dx, okay? So I'm going to get minus half x times cosine 2x plus half integration cosine 2x dx. And for this generated, the third generated integral, I no longer need to use integrated by part, because I can integrate that easily. So I'm going to get a minus half x cosine 2x plus a quarter, half times half sine 2x. And okay, but you can also add another c at the end. Okay. Finally, substitute whatever you obtained for I2, the second integral, into the main calculation here. So you're gonna get half x squared times sine 2x. Make sure you realize it's a subtraction here. Subtract a bracket term, half x cosine 2x. And add a quarter sine 2x. Of course, you can put a combined plus c at the end, okay? I actually put the c1 here, but doesn't matter because you use the c here, or c1, c2. The first one is c1, the second one is c2, etc. Okay? As long as you put an integration constant here, that will be fine. Half x squared sine 2x plus half x cosine 2x, subtracting the quarter sine 2x plus c1. Okay, that is your final answer. All right. Right. Up to question 11. We're already an hour and 20 minutes finished. We still have 12 to 19. Okay, all right. Well, I need another sprint run, so let me just finish my second copy and finish all the rest for this exam. Wow, we still have exam 2 sample questions. Go. All right, so the vectors A equals to 2i minus 3j plus k and B equals to 4i plus 2j minus 3k lie in the plane that passes through the point 3, 2, 1. Find the Cartesian equation of the plane. So remember, your plane is defined by a point. This is your P 3, 2, 1. And the plane needs a normal vector. How do you find a normal vector? You have two vectors. Just do the cross product, okay? Normal vector. N is going to be A cross B, okay? So I'm setting out a 3 by 3 determinant, I, J, K. 2 minus 3, 1. 4, 2 minus 3, okay? So I'm going to do I minus 3, 1, 2 minus 3, minus J, 2, 4, 1 minus 3, plus K, expanding along the first row, 2 minus 3, 4, 2. Okay, I is going to be 9 minus 2 minus J minus 6 minus 4 plus K, 4 minus 12. This is going to be 16, I suppose. So I'm going to get 7i plus 10j plus 16k. Easy, level squeezing. And then just recall that equation of plane. We are going to say n1 times x plus n2 times y plus n3 times z equals to some constant, let's say k here, okay? Or if you wish, you can use capital lowercase d, doesn't matter. So N1, N2, N3, these three numbers are the components of your normal vector. Or if you really want to find the vector equation, it's R minus your point in this plane dot product with normal vector equals to 0, okay? But the question wants you to use the Cartesian equation. That's why I'm using N1x, N2y, N3z, etc. So 7x plus 10y plus 16z equals to k. Remember, you have 3 to 1. Point is 3 to 1. So I'm going to say 21 plus 20 plus 16 equals to k. Therefore, your k equals to 57, okay? So now, therefore, the equation of the plane pi1 is going to be, let this be pi1, okay? 7x plus 10y plus 16z equals to 57. That's it, okay? All right, simple as that. Now let's have a look at a question 13, okay? It's question 13. Question 13, we have two parts, part A and part B, okay? Now, find the equation of the plane that passes through a point P, Q, and R. Well, the similar procedure as in question 12, but I suggest you put a diagram here, okay? P, Q, PR. Because I really need two vectors to determine the perpendicular vector for the plane, okay? Now, let U equals to P to Q, okay? P to Q. And the V equals to P to R. What that means is, okay, from P to Q, 1 minus 3, endpoint minus start point, minus 2i, minus 1 minus 3, minus 4j, and 2 minus 6, that will be minus 4k, okay? But actually, if you do Q to P, that's fine, okay? I'm just doing P to Q. The reverse thing is fine. R to P, R, that will be 5 minus 3, that will be 2i, 2 minus 3, that will be minus j, 0 minus 6, minus 6k, okay? So the normal vector is going to be U times V, you cross multiply V. I, J, and K. Minus 4, minus 2, minus 2, minus 4, and a minus 4. 2 minus 1, minus 6. Minus 4, minus 6, that will be 24. Subtract 4, okay? Minus J, minus 2, minus 6, that will be 12. 12 subtract minus 8 plus K. We have minus 2, minus 1, 2, minus 8. Okay, so you should have 20i minus, for example, minus 20j plus 10k. Very simple numbers. So it also works to use N2 equals to 2i minus 2j plus k plus 1k, because that's just 1/10 of the normal vector we found. And with a smaller number, it's easier to work with. And the same direction, it's still perpendicular to both U and V, okay? So I'm going to use the dilated version, the simpler version of this normal vector to find the equation of the plane. Remember the plane, you could either use P, Q, or R, as long as the point is within that plane, okay? use point P. We know 2x minus 2y plus 1z equals to k. And subbing 3, 3, 6. We have 6 minus 6 plus 6 equals to k. Therefore, k equals to 6. Don't forget the equation of the plane is going to be 2x minus 2y plus z equals to 6. You need the equation, okay? So that's the Cartesian equation. But the question didn't specify whether you want a Cartesian equation or vector equation. So I'm going to assume that we are using the Cartesian equation, okay? So that's the end of question 13. Part A finished, but we still have part B to go. Find the point of intersection of the line given by I equals to 2i plus 5j, where t is any real number, with the plane given by 2x minus 2y plus c equals to 6. Wow, very good. Yep, that confirmed our answer to previous part. So now I'm going to convert this vector equation of the line back to the, let's say, parametric form. So R has three components, x, y, z. X equals to 2i plus 2t. J, 2ti. So x equals to 2 plus 2t. Y is going to be 0 minus 40. Okay, look at the j component. And the z is going to be 5 minus 3t. Okay, so I'm going to chuck in three of them. Chuck three of them into the equation. I'm going to get 2 loss of 2 plus 2t. Minus 2 minus 40 plus 5 minus 3t equals to 6, okay? 4 plus 4t plus 8t plus 5 minus 3t equals to 6. So 12 minus 9, that would be 90, okay? 12 minus 3, that's 90. And 9, 6, whoa, that's going to be 6 minus 9, which is minus 3. So t is going to be minus 1/3, okay? Remember, the point of intersection should be expressed as a coordinate triple, okay? In the 3D plane, in the 3D space. So I'm going to say R minus 1/3. This is going to be 2i plus 0j plus 5k minus 2 over 3i plus 4 over 3j and minus plus. Oh, plus 1k. Nice. So this is going to be, well, 4 over 3i plus 4 over 3j and plus 6k, okay? So the coordinates should be 4 over 3, 4 over 3, comma, 6. Okay, that's the second part of the question. All right, now let's have a look at the question 14. Okay, question 14. So find the angle between the plane given by 2x plus y plus z equals to 7 and the line given by r equals to 11i plus 4j plus 3k times plus t times I plus 2j minus k. T is a real number. So a diagram here will be helpful, but not compulsory. Well, why do I get a circle? Doesn't matter. I just use that a circle to picture something. So this is my pi, the plane. 2x plus y plus z equals to 7. Look at the equation. What can you extract from the numerical information? Well, a perpendicular in red, perpendicular line or vector in red. This is my normal vector. This is going to be 2i plus 1j plus 1k, okay? And how about the equation of the line? The equation of the line, well, the direction is determined by the multiplied vector after parameter t. So I'm going to assume that, okay, this is the equation of the line. The direction vector is 1i plus 2j minus 1k. And we want the angle between the plane and the line. So it's actually looking for this angle here. But now, because we have vector n and a vector d, we can use dot product first to get half pi minus theta, okay? So what I'm trying to do here is, okay, dot product. Use dot product for angle. Cosine half pi minus theta, okay, equals to 2i plus 1j plus 1k dot 1i plus 2j minus 1k divided by the magnitudes multiplied together. So I should have root 4 plus 1 plus 1 times root 1 plus 4 plus 1. That will be 2 times 1 is 2, 1 times 2 is 2, and 1 times minus 1, minus 1. Root 6 times root 6. So I'm going to get a 3 over 6, which is half, okay? Cosine half pi minus theta equals to half. And we are talking about, let's say, the acute angle or a possible obtuse angle within 0 to pi. So cosine pi over 3 is going to be half. So half pi minus theta is going to be pi over 3, and theta is definitely pi over 6, or in degrees, 30 degrees, okay? So that is my answer to question 14, okay? Hopefully you can use a diagram similar to this one to picture what's happening here. It's basically finding the angle between the line and the normal vector and use 90 degrees to subtract the angle you just find, okay? So I'm going to say, all right, question 15, very nice. Vector equation of the line through the points, this and that. So basically, we know R is going to be, let's say, A plus T times vector D, okay? Vector D is the direction vector, which is A to B, okay? So I'm going to say 5 minus 3 is 2i, 2 minus 1 is 1j, minus 6 minus 1, which is minus 5k, and the vector equation RT is going to be 3i plus 1j minus 1k bracket plus t times 2i plus j minus 5k. Of course, if you wish to use vector B here, that's also possible, okay? You don't need to write both cases out, but this is just the intended answer. And do you want to, if you want to merge the two vectors together, that's also fine, okay? But one detail, I must address one detail. Because that's a line, it's not unidirectional, okay? It's not going from A to B like this, or it's not simply going from B to A like this. It's two directional, okay? So you're not just stating T is greater than or equal to 0. You need both directions. Therefore, either version here, you should have T is any real number, okay? Because that's describing a geometry item, a line, both directions. All right, find the sine of the angle that the line makes with the plane. So what is that? Well, I'm still using that analogy. Pi x plus 2y minus z equals to 9. The perpendicular vector is here. And if the line goes through here, okay? Sine of the angle. This is theta, this is half pi minus theta. Well, we have to use the dot product again. Let's say cosine half pi minus theta equals to the direction of that line, let's say 2i plus 1j minus 5k dot product 1i plus 2j minus 1k divided by square root 4 plus 1 plus 25 times square root 1 plus 4 plus 1. Okay, so I'm going to get 2 times 1 is 2, 1 times 2 is 2, minus 5 minus 1, that would be 5, divided by root 30, and the root what? Root 6. So I'm going to say this is going to be 9 over root 30 times root 6, okay? Simplify that or not, I'm not too fast, but I'm better simplify that. That would be root 3, root 10, root 3, root 2, 9. Okay, looks like we do need to simplify that bit. So that will be 3 over root 20, which is 3 over 2 root 5, okay? And that will be 3 root 5 over 10 if I multiply both top and bottom by root 5. But now the question wants the sine of the angle. So it's actually looking for sine theta. Sine theta, according to some complementary property, okay, is just cosine half pi minus theta, okay? This is from year 11 math method, okay? Symmetry. So my answer is 3 root 5 over 10, okay? That's it. All right, now let's have a look at the next part. The position of a particle after t seconds is given by this function here. T is greater than or equal to 0. Good. It's definitely a time variable. And the components are measured in meters, t seconds, SI units. Find the time at which the minimum speed occurs. Speed minimum, and calculate the minimum speed. Give your answer in meters per second. So to get a speed, you basically need to get your velocity, which is the time derivative of position vector, 2ti plus 5j plus 2t minus 16 bracket k. Now my speed is going to be the magnitude of velocity. Well, this is going to be 4t squared plus 25 plus 2t minus 16 whole thing squared, okay? Now, to minimize this object, you need to either use calculus or use some basic properties of our quadratic functions. What I'm trying to do is to simplify the square root first. Well, you may not want to do that, but here 40 squared plus 25 plus 40 squared. Well, I need to make that square root longer because I have multiple terms. Minus 6040 plus 16 squared, that would be 196, I suppose. Whoa, quite a bit. So square root of 8t squared minus 64t plus, that will be 196 plus 25. Okay, so 196 plus 20, that will be 216, 216 plus 5, 221. Hopefully I get it correct. Okay, let me just have a closer look. 16, oh, actually, no. Be very careful with that. 16 squared, that will be 256. So I'm going to get a 281. That should be the correct answer, okay? All right, now let s of t, that's your speed function, okay? your S dash t is going to be 16t minus 64 divided by 2 roots 80 squared minus 64t plus 281. For the minimum value, you want to equate the derivative to 0. So 16t minus 64 equals to 0, t equals to 4, okay? So now I've got a t equals to 4 here. This is when the speed is minimum. So minimum speed is going to be s of 4. So I'm going to say it's root 8 times 16 minus 64 times 4 plus 281. So it all comes to the simple calculation problem in year 7 now. So 8 times 16, that would be 128 minus 256, I suppose, plus 281. So all comes down to 281 subtract 128. And the answer should be, okay, 153. 153. Well, is that the final answer? Looks like we have a 3 at the end. So let's try 153. If it's divided by 3, 51. Oh, 51, is that divided by 3? Divisible by 3. Yep. So actually, we should realize this is 3 root 17 meters per second. Okay. All right. If you didn't simplify root 153, well, I don't think that will be a very big problem, but it's always better if you can simplify that correctly, okay? Because that's not very hard. But if you can't see that directly, don't worry. I wouldn't say there is much penalty for that, but okay, let's just move on. Okay, now 2 planes have equations x plus y minus z equals to 3 and 2x minus y minus 2z equals to 4. Given that the angle between 2 planes is theta, find secant theta, which means I'm going to find cosine theta first and take the reciprocal, okay? So the idea is, okay, I'm looking at a cross-section between 2 intersecting planes. So this is plane 1, this is plane 2. So now if you have a perpendicular vector like this and another perpendicular vector like this, basically you are looking at the angle between them, which is also, by some simple geometry, angles between them, okay? So you are looking at the dot product between 2 normal vectors. Now let's say cosine theta equals to n1 times n2 divided by n1, n2 magnitudes, okay? So what is my n1 and n2? Just write them out. n1 is 1i plus 1j minus k. n2 is going to be 2i minus j minus 2k. All right, 2 times 1 is 2, minus 1 times 1, and plus 2 divided by root 3 and root 4 plus 1 plus 4, 9. Easy. 3 over 3 root 3, okay? Cancel them out. You get 1 over root 3. But don't forget, you need to answer the question. Therefore, your secant theta is going to be root 3, okay? So basically, that's what you're going to get for question 17. Easy. All right, now let's have a look at question 18. The position vectors A, B forms 2 sides of a triangle. Find the area of the triangle in the form C root D. C, D are natural numbers. Well, you need to make sure. Yep, this time you have to put your answer in this form. If the question didn't specify the required form. Any equivalent answer, as long as correct, should be accepted. But now this form is articulated and is stipulated. You need to follow that form. But anyway, because we know the two vectors, for example, A is here, B is here, they should span out to form a parallelogram. And this vector, normal vector to both vector, has length same as the area of the parallelogram. So what I'm trying to do is find the triangle's area. So I just need to find the magnitude of the cross product and divided by 2. Area of triangle is half A cross B magnitude, okay? So A cross B is going to be IJK. 2 minus 4, 2. 1 minus 2, 3. So this is going to be I times minus 4, 3, minus 12, minus 4, plus 4, minus J, bracket, 2 times 3 is 6, minus 2 times 1, minus 2, plus K, bracket, 2 minus 2, 2 minus 2, that's minus 4, multiply together, subtract. Subtracting minus 4, oh, cancelled. So I'm going to get, let's say, yep, minus 8I minus 4J plus 0K. Okay, some easy number to work with. Not very bad. So now, magnitude of A cross B, which is your normal vector's length, is going to be root 64 plus 16 plus 0, which means this is going to be root 80. Of course, it's not the final answer. You need to write it as 4 root, let's say 5, okay? Because that's 16 times 4, 5. But is that a final answer? Of course not. The area of triangle is half times 4 root 5, which is 2 root 5. Units squared, okay? So this is your final answer, okay? 2 root 5, and C should be 2, E equals to 5, or technically speaking, should somebody write this as, now, bear with me, root 20, we could argue that C equals to 1, D equals to 20. That's an interesting one, okay? Well, I'm not entirely sure, so let's better move on to the last question eventually. Okay. A parallelogram OABC has vertices OAC. Find the values of M if the area of the parallelogram is 4 root 5. Well, I suspect this is a variation of the question before. Yep, very similar. So what I'm doing here is I draw a nice parallelogram, but make sure you label the 4 vertices in one orientation. You're not labeling them in the zigzag fashion, okay? You're labeling them like this, or that's also fine. Just make sure you rotate once, okay? You don't change the direction like zigzag, no. So what I'm looking at is this and this, okay? Let's say this is small a, this is small c. You have a normal vector here, perpendicular to both vector. Notice that the magnitude of the normal vector is equal to the area of parallelogram, okay? So how do you get that? N equals to A cross C, okay? A cross C. So I'm going to say I, J, K. 1, 2, neg 1, 3, M1, okay? Pull it out and expand accordingly. 2 times 1, that's 2. Subtract negative m plus m. 1 times 1 is 1 minus 3. These two together. And m, 1 times m. subtract 2 times 3 minus 6. Okay, so I'm going to get 2 plus mi minus 4j plus m minus 6k. Well, nice. All right, and what I'm also doing is take the magnitude, okay? So since absolute value of n, the magnitude of n is 4 root 5, which is root 80. I'm going to say m plus 2 squared plus 16 plus m minus 6 bracket squared equals to, what I'm doing here is n magnitude square equals to 80, okay? Squared both sides. You just find a nicer equation without a square root once you squared both sides. So m squared plus 4m plus 4 plus 16 plus m squared minus 12m plus 36 equals to 80. And 2m squared minus 8m plus 56 subtract 80 equals to 0. So 2m squared minus 8m minus 24 equals to 0, dividing everything by 2. M squared minus 4m minus 12 equals to 0. Back down to the elementary level, year 9 quadratic stuff. So m minus 6, m plus 2 equals to 0. Easy peasy, lemon squeezy. M equals to 6, m equals to minus 2. Do I need to reject any solution? No, because m is a real number, okay? Find the values of m if the area of the parallelogram is 4 root 5. So I'm going to take both of them. Unless there are other restrictions that could allow just one value, then I need to reject the other, okay? All right, hopefully you find this video somewhat helpful, and I will see you next time to record the sample exam 2 questions, okay? I walk through for them. Thank you very much, and I'll see you next time. Ta-da.